Terraform module is a set of Terraform configuration files in a single directory. Now, even a simple configuration consisting of a single directory with one or more .tf files, that is Terraform files, is a module. When you run Terraform commands directly from such a directory, it is considered to be the root module. Hi everyone, this is Kavya from Edureka. Welcome to today's session on Terraform modules. Before we begin, I'd like to address the agenda. Firstly, there'll be an introduction to what is Terraform and why we need to work with Terraform modules. Then we'll move ahead and understand what is a Terraform module and conclude this session by creating your own Terraform module. I hope the agenda is clear. Kindly take up this time to subscribe to us and do not forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn more about new trending technologies, visit our page, the link to which is given in the description box below. So without much ado, let's get started. Introduction to Terraform. Surprisingly, a lot of them skip over Terraform modules for the sake of simplicity, or so they think. Later on, they find themselves going through hundreds of lines of configuration code. If you're someone who understands that Terraform is a tool to manage infrastructure as code, then let's move ahead and understand what does a Terraform module really do. Even when you do not create a module intentionally, if you use Terraform, you're already writing a module which is called the root module. So any Terraform configuration file that is a .tf file in any directory, even it can just be in one directory, forms a module. So we should understand, so in short, that is a module. Any Terraform configuration file within a directory is a module. I hope that is clear. Now let us move ahead and understand what does this Terraform module really do. So the Terraform module really allows you to create a logical abstraction on the top of some resource set. In simple words, or in other words, I could say that a module really allows you to group resources together and then reuse this group later, possibly many a times. So you could compare modules with packages in Python or even functions. So you can reuse packages and you can reuse functions. So that is exactly what a Terraform module also does. Let us understand what is a Terraform module in detail. So let's assume now that we have a virtual server with some features hosted in the cloud. Now, what set of resources might describe that server? For example, the virtual machine itself created from some image, and also an attached block device of a specified size for additional storage. We'll also need a static public IP that is mapped to the server's virtual network interface. We will also have a set of firewall rules to be attached to the server. And there are many other things like another block device, additional network interface, and much more. Now, assume that you'll need to create this server, this module server, with a set of resources many times. This is where modules are really helpful. You don't want to repeatedly use the same configuration code over and over again to you. So this is how you call a module, that is to use it in a configuration file. Here we create 5 instances of the server using a single set of configurations in the module. You can see that Terraform supports this keyword called count, which will allow you to create any number of instances in your TF file. So that is what really a Terraform module does. Now let's talk about another situation. You would probably want to create more than one module. So there are some common examples like a network of a virtual private cloud or a static content hosting, that is buckets, a load balancer and its related resources, a logging configuration, or whatever else you consider a distinct logical component of the infrastructure. Now let's say we have 2 different modules. The first module, as you can see on the screen, is named server. The second one is named network module. The module that is called as network is where we define and configure our virtual network and place servers in it. So you have 2 different child modules called within the root module. So once we have custom modules, we can refer to them as child modules, and the configuration file where we call child modules relates to the root module. And a child module can be sourced from a number of places like the local paths, the official Terraform registry. And if you're familiar with other registries like the Docker registry, then you already understand the idea of Terraform registry. The child module can also be sourced from a Git repository, a custom one, or GitHub or Bitbucket, anywhere you'd like to get them from. And finally, you can also source them from an HTTP URL to a .zip archive with the module. So this is all you really have to know about Terraform modules. This is briefly to understand the basics of Terraform module, what they really do, how they're created, and can you create many more modules? And the answer is yes. Now let's move on to the next part of the session and understand why Terraform modules. As you manage your infrastructure with Terraform, you will obviously create increasingly complex configurations. There is no intrinsic limit to the complexity of a single Terraform configuration file or directory, so it is definitely possible to continue writing and updating your configuration files in a single directory. However, if you do, you may encounter several problems. The first problem would definitely be by understanding and navigating the configuration files will eventually become very difficult. The second problem would be updating the configuration file will become much more risky, as an update to one section may cause unintended consequences to other parts of your configurations. The third problem is there will be an increasing amount of duplication. Another feature of Terraform is reuse configuration. Writing all of your configuration from scratch can be time consuming and error prone. Using modules can not only save time but also reduce costly errors by reusing configuration written either by yourself, other members of your team, or other Terraform practitioners who have really published modules for you to use. You can also share modules that you have written with your team or the general public, giving them the benefit of your hard work. The final feature of Terraform is that it provides consistency and ensures best practices. Modules also help to provide consistency in your configurations. Not only does consistency help complex configurations very easy to understand, it also really helps to ensure the best practices are applied across all of your configuration. Now, let me explain this with an example. Cloud providers give many options for configuring object storage services. They provide services like Amazon S3 or Google Cloud Storage Buckets. I'm sure if you're someone who's working with cloud is very much aware of this. There have been many high profile security incidents involving incorrectly secured object storage. And given the number of complex configuration options involved, it is really easy to accidentally misconfigure these services. Now, what modules can do here is it can help you reduce these errors. Let me explain this with an example. You might create a module to describe how all of your organization's public website buckets will be configured, and another module for private buckets used for logging applications. Also, if a configuration for a type of resource needs to be updated, using modules allows you to make that update in a single place and have it be applied to all cases where you use that module. So this is one way of solving all of the problems that you've been facing without modules. Now let's get right to the point and understand what is a Terraform module. A Terraform module is a set of Terraform configuration files in a single directory. Even a simple configuration consisting of a single directory with one or more .tf files is a module. So when you run Terraform commands directly from such a directory, it is considered the root module. So in this sense, every Terraform configuration is part of a module. You may have a simple set of Terraform configuration files such as license, readme.md, main.tf, variables.tf, outputs.tf. And in this case, when you run Terraform commands from within the minimal module directory, the contents of that directory are considered the root module. So Terraform commands will only directly use the configuration files in one directory, which is usually the current working directory. However, your configuration can use module blocks to call modules in other directories. So when Terraform encounters a module block, it loads and processes that module's configuration files. A module that is called by another configuration is sometimes referred to as a child module of that configuration. So this is all you really have to know about how modules work, what are its features, what are the advantages and benefits of really using them and managing your code. So now what we're going to do is we're going to learn how to use module from the Terraform registry. So before we do that, so what I'm going to do is I'm just going to teach you guys how to install Terraform in your local machine. Currently, I'll be working on the Linux virtual machine. That's where we'll be installing Terraform. So now what I'm going to do is I'm just going to click on my web browser in my virtual machine. As I've already mentioned, I'm currently working on my Linux virtual machine, to be specific on Ubuntu. I'm just going to look for Terraform install, and you can just click on download Terraform here. And you can see that you can download Terraform for various OSs, that is Mac OS. You can download for free BSD, Linux, OpenBSD, Solaris, and Windows too. So I am currently working on Linux. So now you can see on the left hand side, you can download Terraform. You can click on the Debian/Ubuntu apt packages. So if you scroll down, you can see repository configuration. So the Terraform packages are signed using a private key controlled by HashiCorp. So in most situations, the first step would be to configure your system to trust that HashiCorp key for package authentication. So we will open a terminal quickly, and I'm going to be executing the first command. Okay, and once that's done, so now I have been successfully logged into my AWS account. And what I'm going to do is I'm simply going to go to services, and I'm going to click on EC2 here. So now what I'm going to do is I'm going to click instances running. So it's going to just redirect me to a page where you can see the number of instances that we've created, its name, its ID, type, all of that. But since there are no instances here, I am just going to let that be. So on the left side, you can see this blue button that says launch instance. I'm going to click on this drop down arrow button, and I'm just going to select the launch instance option. And this will redirect me to a page where it will allow me to choose an Amazon machine image. AMIs are just templates that contain the software configuration required to launch your instance. So what I'm going to do is I'm just going to scroll down here. I'm just going to look for the AMI for my Ubuntu server. And currently I'm working on 18.04 LTS Ubuntu servers. So I have to select my AMI based on this. Just copied this AMI. I'm going to switch back to my terminal. So I've added my AMI number here. And there's another thing that we will have to do here. So I'm just going to quickly go back to my provider AWS. So here what I'm going to do is I'm going to just cross-check the region. Currently it's on US West 2. I'm going to switch back to my AWS account, and I'm just going to, confirm the region that I'm currently working on. Here you can see that I'm working on US East 1. So that's what I'm going to change it to. So once you have provided the region, now what we're going to do is we are going to add an access key and a secret key. So where do you find your access key and your secret key? So now you have an option that says access key, where you have your access key ID and secret access key. For security purposes, I won't be opening this because I have my key ID and my secret access key given here. And you can just create one if you don't have one, download it, and then type in your access key ID and secret access key over here in the provider AWS module. And once we are done with that, we'll get back to the next part of the session. So once I've saved my file, I'm going to clear my screen. Now what we're going to do is we're going to set values for module input variables. Now in order to use most modules, you will need to pass input variables to the module configuration. And the configuration that calls a module is responsible for setting its input values, which are passed as arguments in the module block. Aside from source and version that we discussed previously, most of the arguments to a module block will set variable values. On the Terraform registry page for the AWS VPC module, you will see an inputs tab that describes all of the input variables that module supports. Some input variables are required, meaning that the module does not provide a default value. An explicit value must be provided in order for Terraform to run correctly. Now, within the module VPC block, review the input variables you're setting. You can find each of these input variables that are documented in the Terraform registry. You have name, which will be the name of the VPC within AWS, CIDR block, which describes the CIDR blocks used within your VPC, 𝐂𝐧𝐥𝐢𝐧𝐿, which are the availability zones that will be used for the VPC's subnets, private subnets, public subnets, enable NAT gateway. And if this argument is true, the module will provision NAT gateways for your private subnets. tags which specify the tags for each of the resources provisioned by this configuration within AWS. And you can also review the arguments for the module EC2 instances. So now using input variables with module is very similar to how you use variables in any Terraform configuration. A common pattern is to identify which module input variables you might want to change in the future and create matching variables in your configuration's variable.tf. So let's open the variables.tf file. Now those variables can be passed to the module block as arguments. Not all module input variables need to be set using variables in your configuration. For instance, you might want this VPC to always have a NAT gateway enabled because the application you're provisioning requires it. In that case, using a variable to set enable gateway would be counterproductive. You will need to define these variables in your configuration to use them. If you've cloned the repository mentioned earlier, your variables.tf file will look something like this. Modules also have output values which are defined within the module block with the output keyword. You can access them by referring to the module.modulename.output name. Module outputs are listed under the outputs tab, and module outputs are usually either passed to other parts of your configuration or defined as outputs in your root module. So we will check out the outputs.tf file. In this, you can see that the value of VPC public subnets will come from the public subnets output from the module named VPC. And EC2 instance public IPs is defined as module.ec2 instances.public IP. Now what we're going to do is we are going to initialize our Terraform configuration by running the Terraform init command. Here Terraform has installed the provider and both of the modules your configuration refers to. After this, you can run your Terraform apply to create your VPC and EC2 instances. So when you're using a new module for the first time, you must either run Terraform init or Terraform get to install the module. When either of these commands are run, Terraform will install any new modules in the .terraform/modules directory within your configuration's working directory. You will notice that many more resources than just the VPC and EC2 instances will be created. The modules we used define what those resources are. You can respond to the prompt with yes to apply the changes and continue. And you should see the instance IP addresses in your configurations output. So here it says that in the variables.tf file, we have mentioned the wrong parameter. So that's what we're going to change now. I'm going to clear my screen first, and we are going to make some changes in the variables.tf file. And this is east-1a, and this is east-1b, and finally east-1c. So once that is done, I'm just going to save this, and I'm going to execute the init command again. So now I'm going to execute the init command followed by the apply command. As you can see that apply has been completed, resources added of 14, 4 chained, 0 destroyed. Outputs are the instant public IPs have been given as follows. And also the VPC public subnets are also been given. So now that you have created them, you will also have to clean up your infrastructure. Now that you've seen how to use modules from the Terraform registry, how to configure those modules with input variables, and how to get output variables from those modules, before moving on to the next part of this session, we'll have to destroy the infrastructure you created by running the Terraform destroy command. I'm just going to quickly clear my screen, and I'm just going to execute the Terraform destroy command. You'll just have to respond the prompt with yes, and Terraform will destroy the infrastructure you created. So now that we've learned how to deal with the Terraform registry, with this, we come to the end of today's session on Terraform modules. I hope you had a great time. If you have any queries, feel free to leave them in the comment section below, and we will get back to you as soon as possible. Until next time, thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!